So what happens here is Dictyostelium, when they're in starvation conditions, they will biochemically change to express different genes, so then have different behaviors. And in that process, they will then start signaling to cells around them, and the surrounding starving cells will receive that signal, and they will move towards the origin of that signal. And we call that process chemotaxis. So it's movement towards a chemical. So we are going to mimic that today in the lab. So the process of doing that, you will use one of your Eppendorf's of cells, and work out what volume of that cell solution you need to make 1 × 10⁶ cells. You will take those out into a fresh Eppendorf, and you will spin them down in the microfuge, making sure you balance the microfuge with the equal volume of cells on the opposite side. You will then take them out, you will pour the liquid down the sink, because Dictyostelium is found naturally in the environment. You will add, say, 200 microliters of KK2. This is the red tube in your box, and you will resuspend those cells. So the next bit is a bit more tricky. And I didn't get. So you will have a square piece of 3mm paper, not round but square. What I'd ask you to do is get your KK2, which is in your green bucket here, and you'll pour a couple of milliliters of that onto your lab bench. Now KK2 is phosphate buffer, it's salt water, so there's nothing in it that is dangerous or toxic in any way. You will then get your square of filter paper, and you will bend it, and then you will put that in the middle of your puddle of KK2, and then you will push down the edges such that the filter paper fits with no bubbles onto the bench. You then have an Eppendorf, you then have a rolling pin, a glass rolling pin. Looks a bit like something we use in the lab often. And then you will roll that flat. So what that gives you is an absorbent semi-dry pad. You will then get your small round dish, and inside it you'll see a grey quarter slice of pie. Now that's nitrocellulose membrane. So this is an inert membrane, which when we put cells on top of it, the cells will stay on top, but the media or the phosphate buffer will go through it. So you'll end up with nitrocellulose membrane evenly covered with cells. So you need to get your tweezers, and you pick up your nitrocellulose membrane and you drop it into your KK2. So that pre-wets the membrane, just like that. Okay? So then that's rinsed and wet and all fine. You will then pick it up again with your tweezers, and you will place it on your 3mm. So now you've got your nitrocellulose membrane on an absorbent base. So you can then get your cells, which you've resuspended in a couple of 100 microliters of KK2, and you'll take them up into your pipette, and you will drop by drop distribute the cells onto the membrane, the grey nitrocellulose membrane. So you're trying to do that evenly, but not let the cells flood over the edge of the membrane. And then you wait for a couple of minutes, and you can see all the liquid will be absorbed through the nitrocellulose, and you'll just have cells on the top. So whilst that's happening, you get your quarter pi white filter and you add 600 microliters of the KK2 or the treatment you have in your bucket. Each of you should have your own either KK2, VPA, ethanol or retinoic acid. You will add 600 microliters to your filter in your dish. Then, very gently, you will use the tweezers to pick up your cells with the cells on the top, and you will put them on top of your filter containing your compound. Then you'll put the lid back on. Before you do this, you'll label the bottom of the dish with your name, and then you will give it to Sonia and I, and you can come back to the lab in 24 hours and you can have a look at your development process. Is that okay?